Have you ever wondered how machine learning algorithms group similar data points together? Today, we're going to unravel the secret behind one such algorithm, the k-means clustering. The first move in the k-means game is to specify the number of clusters, kcal, you want the algorithm to create. This choice is often driven by your understanding of the problem at hand. Now, imagine AK dots scattered randomly on a playing field. These are your initial cluster centroids, the heart of each cluster. Next, every player or data point steps onto the field. Each player runs to the dot closest to it, forming K initial teams or clusters. The distance between a player and a dot is typically calculated using metrics like Euclidean or Manhattan distance. Now, it's time for a team huddle. The dots or centroids recalculate their positions by taking the mean of all their team members. They move to this new location, becoming the fresh center of their respective teams. Then we check. Have the dots moved significantly since the last round? If they're still moving around, we go back to reassigning players to the closest dot. If not, or if we've reached a predetermined number of rounds, we call it a day. The game ends and we have our final teams. But here's the catch. The k-means game can play out differently each time depending on where you initially placed your dots. This sensitivity to initial placement can lead to different team formations every time the algorithm runs. To find the fairest game, k-means is often played multiple times with different initial placements, and the game with the lowest total distance between players and their team dots is chosen. Another thing to keep in mind is that k-means assumes all teams should be of similar sizes and shapes, much like spheres. But if you've got teams that are more elongated or not all teams have the same number of players, k-means might not be your best referee. In such cases, you might want to consider other algorithms like hierarchical clustering or DBSCAN. So in a nutshell, k-means clustering is a way to form teams or clusters from a group of players or data points, aiming to keep players in the same team as similar as possible, while maximizing the differences between teams. It's an unsupervised algorithm that can help us find structure and patterns in our data, even when we're not entirely sure what we're looking for. That's the beauty of machine learning, isn't it?